Today, we are diving into a theory that might just flip your entire understanding of reality on its head. It all starts with a simple, but truly profound question.
Think about it. What if the so-called unbreakable laws of physics, the very rules we use to describe everything, aren't fundamental truths at all? What if they're just a point of view?
Okay, so before we go tearing up the physics rulebook, we probably need to know what the rules are, right? Let's start with the constants that make up the official story of modern science.
We're talking about the heavy hitters here. The speed of light, the gravitational constant, and Planck's constant, which, basically sets the smallest possible pixel of energy in the universe. These numbers are treated like they're etched in stone, the unchangeable bedrock of reality. Everything from your smartphone to a galaxy far, far away is built on them. But what if they're not the bedrock at all?
And this is where things get really wild. This new theory comes in and says, hey, maybe we've been confusing two totally different kinds of properties this whole time.
So on one side, you've got structural properties. Think of this as the actual fundamental fabric of reality, the thing itself. And on the other side, you've got behavioral properties. These are the effects, the things we observe that happen because of that underlying structure. It's like the difference between the wood and skin a drum is made of. That's the structure, and the sound it makes when you hit it. That's the behavior. We've been studying the sound, not the drum.
Now check this out, because this is where the pieces start to click into place. The theory argues that a fundamental structural property, like the elasticity of the fabric of reality, is what leads to the behavioral property we measure as the speed of light. The deep down scale and shape of that fabric, well, that leads to what we measure as mass and charge. So here's the kicker. All those constants we thought were the absolute foundation of everything, they might actually just be behaviors, not the structure itself. So if our entire field of physics is built on these behavioral properties, it means we've only been looking at the surface level, and that idea naturally leads to a two-layer model of reality.
And this quote from the source material just nails it. Our science isn't some perfect, high-resolution photograph of reality. It's an interpretation, a view that we have derived from our own limited local observations.
So let's talk about layer one. This is the whole shebang, the true reality. It's not a collection of separate particles and forces, but a single unified object the theory calls space-time, with a capital S and a capital T. It's one coherent fabric with its own structural properties like smoothness and elasticity. Layer 2, on the other hand, is our model of the world. It's the perspective where all our physics theories, all our measurements, and all our experiences live. This layer is created only when we, as local observers, distinguish one part of the fabric from another, creating the illusion of separate objects and the rules that connect them.
And this just illustrates the whole process perfectly. You start with one single object, space-time. Then, an observer, that could be us or a measuring device, notices a local change. The very act of observing and distinguishing creates our derived concepts, like matter and energy. And finally, we build all of our Layer 2 physics theories to explain these derived concepts, not the original unified fabric.
Okay, you really have to pay close attention here because this is a huge distinction. The unified space-time of Layer 1 is not the space-time from Einstein's theories. In Layer 1 space-time, the elasticity can vary, but time itself is rigid. Our Layer 2 physics model is the opposite. It assumes elasticity is constant, which gives us the constant speed of light, but that time is flexible. These are fundamentally different concepts.
Okay, I know, this is all fascinatingly abstract, but so what? Why does this two-layer model even matter? Well, it might just offer a brand new way to tackle some of the biggest unsolved mysteries in physics.
First off, it reframes our most basic ideas. In this model, a particle isn't a fundamental little bit of stuff. No, it's simply what we perceive when our perspective focuses on a specific little ripple or shape within the unified fabric of space-time. Matter itself becomes a product of our view.
And that brings us to the really weird stuff. What about the spooky, non-local behavior we see in quantum mechanics, like two particles being instantly connected across vast distances? How does this model handle that?
This, to me, is the model's most elegant move. It says quantum weirdness isn't weird at all. Entanglement only seems strange because we are forcing a Layer 2 perspective, the idea of two separate particles, onto a Layer 1 reality where they were never separate to begin with. They are just different parts of the same single object. So entanglement isn't a mysterious connection, it's the underlying unity of Layer 1 just poking through into our limited view. Quantum physics isn't something that needs an interpretation, it is the interpretation.
So, what's the big takeaway from all of this? This two-layer model doesn't just offer cool solutions to physics puzzles, it suggests a powerful new perspective on what science itself actually is.
So, the crucial point is this. We're shifting from seeing physics as a description of how nature actually is to seeing it as a powerful, useful description of how we experience and measure nature. Layer 1 is the thing itself, a unified whole. Layer 2 is our view of that thing, built from distinction, measurement, and the concept of separate parts.
And that leaves us with a profound final thought. If every theory we have, from Newton to Einstein to quantum mechanics, exists in layer 2 as just a perspective, it forces us to ask, what does the unified, unfiltered reality of layer 1 actually look like? We may not have the answer, but knowing that's the question we should be asking, well, that's the first and most important step.